Hello there, and welcome to XLS Design. In today's tutorial we're going to be drawing a 3D metric coarse thread bolt, and on the screen here you can see a picture on the right hand side of the finished bolt that we will be drawing. A couple of things to note: that there is a 30-degree chamfer on all of these corners on the head of the bolt. The bolt also has a very thin washer plate attached to it, and also the ends of the bolt also have a 45-degree chamfer on them. The data highlighted on the left hand side here in a bluey grey colour is basically the data that we're going to be using. And down below I have pre-put in a few sizes that we will be referring to throughout this tutorial. The profile shown in red here is the profile that we will be using to cut our thread through the bolt. Okay, the first thing to do is to speed up AutoCAD slightly. Now, if you're using Windows 7, then what we would like to do is find a blank space on our desk. Let's open up AutoCAD. Now, I'm using AutoCAD 2012. So the first thing we want to do is start up on the coordinates panel here. I'm going to change our user coordinate system from world to front, and as we can see our crosshairs have now changed. Okay, the first thing we're going to do is the main body of the bolt. So we're going to start by typing in rectangle, so REC, and as we can see AutoCAD has auto-completed it for us, so I'm just going to click on there. Right, it's asking us for our first corner point, so we'll start at 0, 0. So let's type 0, 0 and hit enter. And our next coordinates, well, what we can do is, if we have a look back at our Excel spreadsheet, we know that our bolt is going to be a 16mm bolt, and we know that the length of it is 50mm long. So let's go back to AutoCAD. So our next coordinate is going to be 50, comma, we're going to use half the diameter of the bolt, which is 8, and then hit enter. I'm just going to zoom in down here, and there we have a rectangle which is half the diameter of our bolt. Now what we're going to do is we're going to put a small chamfer on two of the corners here, which is going to act as our 45-degree chamfer. I'll have a quick look at AutoCAD, at Excel, sorry, and the dimension we're going to use is 5/8 of H, and if we look down on my calculations that I have pre-done, we have a measurement here of 1.08. So let's go back to AutoCAD, and we're going to start the chamfer command. You can either type chamfer or go up to the modify toolbar and select chamfer. Now it's asking us to select the first line. Now it's always a good idea to look down on the command line here, and it will actually tell you various bits of information, and it's telling us that distance 1 and distance 2 are actually set at 0 at the moment. And another good thing to remember is any options here that are associated with the command, anything that AutoCAD capitalizes if we look at trim method, we can see that the T and the E are capitalized. So if we typed T and E, we would then get that option. Now we actually want to set our distances, so we could just type D for distance, or on the screen we can right click and we have access to all the options here. So I'm going to select distance, and for our first distance we're going to type 1.08254, hit enter. It's asking us for our second distance, and as you can see by the dynamic toolbar tip, it has selected the first distance that we put in, so all we need to do now is hit enter. Now we have set both of our distances. We just need to select our lines, so we select our first line here near to the apex of where we would like to put the chamfer. And once we've selected it, we need to hit enter, and now it's asking us to select the second line, so we'll select the other line, and there we have it. We have put a chamfer on it. Now, as the chamfer was the last command that we used, if we hit enter, it will restart the command. And so now we can just select our lines, because if we look at the command line, our distances here are already set. So we'll click one line there and the other line, and that's it. We now have another chamfer on the other edge. Okay, what we now need to do is we now need to convert this. If I click on it, the quick properties box will pop up, and it tells us that we've created a polyline and it's closed. It's very important that we check that we have created what we want, and in this case it's a polyline and it must be closed. So I'm just going to hit escape. Right, our next command then is revolve. Now we can select this from the modeling tab, so I'll select that, revolve. It's asking us to select the object, so we'll select our rectangle and then hit enter. Now it's asking us for an axis. Now our axis, we're going to use the bottom line, so I'll click on one point here and click on the end point here. It's now asking us for an angle of revolution, and if you look at the command line, anything between the less than and greater than sign is going to be the default value. So it's already selected 360 degrees. So rather than us type in 360, what we can do is just hit enter. And there we have it. If I click on this now, it should, instead of being a polyline, it should now be a 3D solid, of which it is. I'll push escape. Another way to check that we've created a solid, we could, instead of using 2D wireframe, we could click on a different view like conceptual, and as you can see, it is now a solid bar with a chamfer on either side. So let's go back to 2D wireframe. Right, the next stage is to draw the actual thread profile. So in order to do that, we're going to change our user coordinate system from front back to world. So we'll click on world, and what we now want to do, because we're going to draw our thread profile, our coordinate system is actually on the bolt here. So what we're going to do is we're going to move this away from the bolt, so as we draw our profile we're not interfering with the bolt. So on the coordinates panel, we need to find origin. So I'm going to click on origin, and as we've got ortho on, it will constrict our crosshairs to 90 degrees. So I'm just going to move it anywhere away from the end of the bolt here and click. And I'm going to zoom in a little bit now as well, because our profile is quite small. So we'll start by invoking the line command. So L for line, or actually type line, hit enter, specify first point. So we'll start on our crosshairs, so we'll type 0, 0, hit enter. Now the length of this line, if we have a look at our Excel spreadsheet, the first line we're going to be drawing is this line across the top here. Okay, and the length of that line is going to be, I thought I had it right, it's going to be the pitch minus P divided by 8. So we can see P divided by 8 here, and we know the pitch, and I've worked it out down here, and it comes to 1.75. So our first line we're going to draw towards the bottom right hand corner, and as long as we drag our crosshairs in that direction, we can just type 1.75 and then hit enter, and that's it. Our lot. Specify. Right, hold up. Let's push enter again to get out of that command. Right. So if I zoom in now, I should have my line here. Click on it. Yes, length 1.75. Okay. Let's push escape. Okay. Let's start the line command again. Hit enter, and I pushed LI. If I look at the command line here, this is where it pays to read the command line, and it started the list command, which I don't want. So I'm going to push escape, and let's type L for line. Select it on the dynamic toolbar tip. Alright, and it's asking for first point. Now we want to start in the middle of this line, and as we can see, it's not snapping to that. You could go down to your object snap here, right click, and have a look at the settings and put a midpoint snap and activate a midpoint snap. Another way of doing that is to hold down the shift key and then right click, and this will give you an option, and this will give us a temporary object snap. So I'm going to select midpoint, and there we have it. I'm going to click on the midpoint, drag my crosshairs towards the bottom left hand side of the screen, and this time the measurement's going to be slightly different. So if we have a look at our spreadsheet again, the dimension that we require this time is going to be h minus h divided by 8. So we've got h here because we're going to be drawing this right down to the apex. We're going to be drawing this triangle. As we can see here, this is h minus h divided by 8. So back to AutoCAD. So I'm going to drag my crosshairs towards the bottom left of the screen, and I'm going to type 1.51556 and hit enter. Now the line command is still active, and while it's active, what I'm going to do is drag my crosshair to the corner of the first line that we drew, and then hit left click. So that's drawn one side of the triangle. I need to draw the other side of the triangle here now. So to get out of the line command, I'm going to hit enter. Now if I hit enter again, it will restart the line command. So let's hit enter, and let's start at our origin point, left click up to the apex of our triangle and left click, and then hit enter to escape from the line command. So there we have our triangle profile. If we select the middle line and then hit the delete key on the keyboard. That will get rid of that. Okay, the next thing to do is to put a fillet on the apex of our triangle. So you can either type in fillet or go up to the modify toolbar and select fillet. And if we look down at the command line, it says that the radius is actually 0, which is obviously no good for us. So I'm going to right click, and from the options I'm going to select radius. Now, referring back to our Excel spreadsheet, we can see that the radius here is 0.144 times the pitch. So you can pre-work that out, which I happen to have done down here, and it comes out at 0.288. So back to AutoCAD, and let's type in 0.28868 and then hit enter. Right, now to select our objects. So we'll select near the apex one line, select the other line, and there we have our fillet applied. Now, as we can see at the moment, this is comprised of individual lines and an arc. Just hit the escape key, and what we need to do is we need to join all of these together. Otherwise, later on when we use this profile to sweep down the body of our bolt, we will create a surface rather than a 3D solid. So for this one, I'm going to type PEDIT for pedit, and it says select polyline, or, and in this case I'm going to right click and select the option multiple. It's now asking us to select objects, so I'm going to select the complete profile, then hit enter to end the selection. Convert lines, arcs and splines to polylines. It's already put in a Y, so for yes, so I'm going to hit enter. It says enter an option. I'll select the option join, so that they will join together. Enter fuzz distance, that's set as 0, and we'll keep it as 0. We now have more options, but we've completed our task, so to get out of this command I'm going to hit enter again. And now if I select our profile, it's telling me that it is now a polyline. And the other thing to check is that it is actually closed as well. Otherwise this will cause problems later on. So I'm going to hit escape. I'm now going to zoom out and so that we can see the body of our bolt. And what we are now going to do is we're going to create a helix on the end of the bolt here, so that we can sweep our profile down. So the first thing to do is to change our user coordinate system again, and this time we're going to change it to right, so that we are now drawing along this plane. If you look at your Y and your X here. So as we want to start our helix at this end of the bolt, we know our bolt is 50mm long, so I'm going to type helix, so HELIX, and then hit enter. It says specify center point of base, so in this case it's going to be 0, 0, 50, because that is the length of our bolt. I hit enter, and as you can see we are now on the end of the bolt here. Now if we look at the command line, or in fact as I move my crosshairs, I am getting the option, hold up, there it is, specify base radius. So that wants to be the radius of our bolt, which is 8mm, as it's a 16mm bolt. It's probably a good idea to follow the command prompts down on the command line here. So it's now asking for the top radius. It's entered the default value of 8 in here, so to accept that I'm just going to hit enter. Right, there's now one option that we need to alter before finishing this command. So if we right click, I'm going to alter the turn height. Now this turn height is going to be the pitch of our bolt, which for 16mm bolt on a metric coarse thread happens to be 2mm. So back to AutoCAD. So enter in 2, hit enter, and the helix is now set to the pitch of the bolt. So what we need to do is drag it to the top left hand corner, and I'd advise dragging the helix a little bit past the end of the bolt, because later on it makes selection slightly easier. So drag it past and then just left click, and there we have, I'll zoom in a little bit, we have our helix, and it should start on the 3 o'clock quadrant here if everything has gone okay. Okay, the next step is to sweep our profile along this helix. So if we go up to our modeling tab here and we select the sweep command, it's asking us to select the objects to sweep. So I'm going to select our profile, then hit enter. Now it says select sweep path, so I'm going to select our helix. Now you can either select it at the front here, or I'm going to zoom out a little bit and I'll select the helix at the back. That way I've got no I can't accidentally select the cylinder of the bolt. So I'm going to click on the helix at the back, and there we have it. AutoCAD's done it. So if I zoom in, right, yes, there was a couple of things that I should have changed before we done that. So right, what I'm going to do, I'm going to go up to the undo button and undo sweep. Right, I'm going to start the sweep command again. Sweep, select objects, so I'm going to select my profile, hit enter, and before I select the sweep path, right, the options that we should have changed, if I right click, we're going to select alignment, and I'm going to select no. Then I'm going to right click and I'm going to select our base point. Now our base point wants to be the corner of the triangle nearest the body of the bolt. So I'm going to click on there. Now I can select my sweep path by selecting the helix. And there we have our profile swept along the helix. Now I can click on this profile and our properties should tell it it's a 3D solid, which is good. So I push escape to get out of that. Okay, so if I select everything here, it now tells me that I have two solids, which is good. We have the body of the bolt and we have the helix, which has wrapped itself around the bolt. So what we now need to do, I'll just push escape, we now need to subtract the volume of the helix from the body of the bolt. So to do that, what we'll do is we'll change our view to conceptual, and you'll see why in a moment. And that is because when I need to select the body of the bolt, it's going to be slightly easier to click on the end of it, as it's now shown as a solid. So we need to find our subtract command, which is up here on the solid editing panel. So I'm going to click subtract. Now this is a good idea now to read the command line at the bottom. It's saying we need surfaces and regions to subtract from. So we need to select in the center of the body of our bolt here. So we'll select that. Look at the command line. It's telling us it's found one object. So I can now hit enter to end the selection. It's now asking surfaces and regions to subtract. Now we need to select our helix here. You can either select it at the front here or go to the back and select the helix at the back. So I'll select that. Looking at the command line, it tells me it's found one object. So I'm now going to hit enter. And there we have it. It's now subtracted. And we can move around, zoom in a little bit, and we can see that we do now have a thread. The end of the thread may look slightly weird because we had a chamfer applied to that. Okay, the next stage is to make sure that I'm on the southeast isometric view. I'm going to go back to a 2D wireframe view. Just zoom out a little bit. Now the next stage is to draw the head of the bolt. Now obviously all this thread is in the way, so what I'm going to do is I'm going to select the thread and then I'm going to type move. Hit enter. Now specify base point, doesn't matter where you click on the screen, and then we want to drag our crosshairs towards the bottom right corner of the screen, and we're typing a measurement that we can easily remember, and we're typing a measurement of 100 millimeters and hit enter. That's now moved our thread out of the way of our crosshairs, because I would like the bolt head to be at 0,0. It just makes inserting into other drawings slightly easier. So if we have a look at Excel, if you notice we have a very small washer head actually made as part of the bolt head. Now this face washer is, if we look down here, is actually only 0.5 millimeter thick. Okay, so this point here on the face washer, that's where our origin 0,0 is. So back to AutoCAD, and what we need to do is start the circle command. So C for circle, hit enter, specify center point at 0,0, enter. Now the radius is going to be, go back to Excel here, the radius of this face washer is going to be the width across the flats here, which is 24 millimeters. Back to AutoCAD, so half of 24 is 12, so for the radius I'm going to type in 12 and enter. We now need to give this washer face some depth, so up to our modelling tab and we'll select extrude. We'll select our object, then hit enter to end selection, and we drag our crosshairs towards the top left corner of the screen, and we'll type in a height of 0.5, hit enter. I'll just zoom in a little bit, and there we have, if I click on it, it tells me it's 3D solid and its height is 0.5. So let's hit escape. Right, the next part to draw will be the actual main head of the bolts. So for that we want to start on the draw tab, we want to start the polygon command and enter number of sides. I'm going to type 6 as it's a hexagon, hit enter. Specify center of polygon. Now this time it's not going to be 0,0 because we've got a thickness of 0.5 millimeter. We're going to have to set this at 0,0, minus 0.5 and then hit enter. Oh, I made a mistake in typing there. I put a comma instead of a period. Right, now I've hit enter. Okay, our option is going to be circumscribed about circle, so click that, and again because the width across our flats is the same as the circle, we're going to type in 12 and hit enter. Zoom in a little bit, and here we have our hexagon around our washer plate. So the hexagon now needs to have some depth, and if we look back at Excel, we have here thickness of bolt head. We know it's 10 millimeters. We've got 0.5 millimeter for this face washer, so the actual head of our bolt here will be 9.5 millimeters. So up to the extrude command, and we'll click on our hexagon, hit enter to end selection, drag your crosshairs towards the top left hand corner of the screen, and this time we will type in 9.5 millimeters and hit enter. Right, it's coming along. All we need to do now is chamfer the back corners of the bolt head here, and the way that we're going to do that is we're going to create another circle on the back of the nuts here, and then we are going to extrude that circle, but extrude it at a taper angle so that it passes through the corner of the corner of this bolt head, and then we're going to subtract the volume of that from the body of the bolt head, and it will cut the corners off. So let's start the circle command. C for circle, hit enter, and our origin point is going to be 0,0, minus 10, as that's the total height of the bolt head. Hit enter, and obviously our radius is going to be 12 again. Hit enter, and then we have our circle on the very top of the bolt head. So up to the extrude command, we're going to select our circle, so select that and then hit enter. Now instead of just using a normal extrude, what we're going to do this time is we're going to right click and select taper angle. Now as you move your crosshairs around, you will notice that the angle, if it's greater than the diameter of our circle, it's a minus value, and less than would be a positive. So as we want to cut the corners of the bolt head off, we need a minus figure, and the angle is 30 degrees, so our dimension in AutoCAD will be minus 60 instead of 30. So hit enter, and it's now asking us for a height. Now this is quite important. We must make sure we drag our crosshairs in the right direction, so drag them towards the bottom right hand corner of the screen, and as a value, well, we'll just use the bolt head height, which is 10, so we'll type in 10, hit enter. Right, this if I click on that, it's actually a 3D solid, and it has passed through the corners of the nut. I'll just hit escape. So we now need to go up to the solid editing panel, and we need the command intersect. So I'm going to click on intersect, and it's asking me to select objects, and what we need to do now is to select the nut or the bolt head, sorry. So I'm going to zoom in a little bit, make sure I select the bolt head, and I'm also going to select this 3D solid that we have just produced. I just need to be careful that I don't select the washer face here, and then I'm going to hit enter, and there we have it. It's cut the corners of the bolt head off. Okay, the next thing to do is to zoom out a little bit, and we now need to move the main body of our bolt back to its original position. So I'm going to click on the body of the bolt, and I'm going to type M for move, hit enter, click anywhere on the screen, and then move it back towards our bolt head and type the dimension that we moved it before, which is 100. Hit enter. Zoom in a little bit. Right, now at the moment we have separate 3D solids, so we're going to now use a command on the solid editing panel called union. I'm going to click that, and it's telling me to select objects, so I'm going to select everything. Now union will just join all these 3D solids together, so select them, hit enter, and it's now joined all of them together. So if I click anywhere, our quick properties tells us it's just one 3D solid. So we'll change our view from wireframe to conceptual. I'll zoom in a little bit, and if I hold down the shift key, use my mouse wheel, we can actually rotate this, and we can see the head of the bolt has our nice chamfers on there, and our thread all looks okay. That's it. That's the finished bolt. Okay, I also do a tutorial for a 3D nut, and also available on my website are screenshots and instructions on how to produce this. So by all means pop along to my website at xlsdesign.com and have a look. Thank you very much for watching.